jobs and m workers. Each job, as in ith job, will be defined as with its difficulty, which means difficulty of I, and the profit which that job will give. Difficulty will define the difficulty of that ith job, and profit of I will be, if I do that job of difficulty of I, I'll get a profit of I as a money. Okay. And they are also saying I have workers, I have m workers, right? So if I have m workers, so every worker is defined as worker of j. Every worker, like jth worker, I am saying. Now for that jth worker, worker of j is the ability of the jth worker. That is, the jth worker can only complete a job with a difficulty at most worker of j. So I can take, for a worker of j, I can complete a job such that worker of j is more than equal to my any difficulty of I. So with difficulty at most worker of I. So this difficulty can be at most worker of j. I can do all those jobs. Remember this fact which we have inferred. Ultimately, again, they have just given one thing also which is very, very important, that at most one job. A worker can be assigned at most one job, which means a worker, this worker can do at most one job. Out of those n jobs, he can do at most one job. But if he, let's say, choose to do this job, number 2, this worker can also do this job again. This worker can also do this job again. So one job can be performed multiple number of times, but one worker will for sure perform only one job. That is what they have given as an example also. Lastly, we have to return the maximum profit after we assign the workers to the jobs. I have to assign these workers to these jobs and I have to achieve maximum profit, considering I have only one condition, which is this, that I can assign my worker to those jobs whose difficulty is equal or lesser than me. Then, for example, if I have a 4, as again, this is a worker, I will go and have to assign a worker some difficulty. So I will go to 4, which means I will go and check my difficulty. In difficulty array, I will go and look for all those difficulties which are less than equal to my 4, which is 2 and 4. Now for all those 2 difficulties, I can take these 2 jobs. If I can take these 2 jobs, I can take 10 and 20 as my profit. Again, I can choose only one. So it's a question for you. Considering you only had just one worker, you had 2 options of job. What will you try? Remember, maksad nahi bhulna. Your main aim was to get the maximum profit sum. Considering, like, why I say sum is for all the workers combined. I want the maximum profit sum. What will be the answer? Simple. You will try to choose the maximum profit, right? So I will choose the maximum profit, 20. And the best part is I can choose it. Maximum profit. So okay, it is 20. Then I will go on to next worker, which is having a worker of j as 5. Then I can go and choose all the difficulties which are less than equal to 5. Okay, less than equal to 5, less than equal to 5. Okay, not. Okay, less than equal to 5. So I'm good. Okay, less than equal to 5, I can take. I will again choose the maximum difficulty. Okay, again 20. Again, next worker. Now I can choose any of the jobs which have difficulty less than equal to 6. Okay, less than equal to 6, less than equal to 6, less than equal to 6. Yeah, good. Okay, take maximum. Oh, maximum is 30. I will take 30. Okay, number 7. Okay, I can choose any job with having difficulty of less than equal to 7. Okay, choose this. Oh, I cannot choose 8 because it is having maximum difficulty. I can choose this similarly 10. So difficulty is 10, 30. Answer is what? 100, which is 50 plus 50. So one thing very basically we realize that one thing we got to know, we for sure have to choose greedily the maximum profit. But out of those which it's possible for me to take as a worker, what all jobs are possible for me to take, out of all those jobs, I will grab the maximum profit. Now a simple brute force technique says that, bro, for every worker, go on to all the jobs, check for the jobs having difficulty lesser than equal to worker of I. For all those jobs, check their maximum profit value and add that in your answer. So indirectly, for every worker, you are iterating on the entire array, right? And same you will do for all the workers. So as a brute force approach, I can say it will be O of n, like considering I have m workers and n jobs and m workers, I will have O of n to m. For sure, we can see that n into m will not pass. 1e8, in worst cases, in Leetcode, roughly it passes, but it will not pass. Okay, we realize that brute force will not work, but still, we still remember our maqsad. Our main aim that for a specific worker, I should know that what all profits he had, and out of all those profits, I just need to take the maximum profit. There are multiple things in this. Again, for every worker, I'll show you how you will approach via these words as multiple branches. So one task was, okay, for a specific worker, for a specific worker 5, I have to go and look for all the jobs which are lesser than 5. Now, earlier I was doing a linear search to find the difficulties which are lesser than equal to 5. But if I sort this entire difficulty array, it will be very easy for me to do a search in this entire difficulty array. So one thing is, again, whenever I sort, I have to make a pair of them and only then I can sort, because for every difficulty there is a corresponding profit value. So I cannot afford to lose the combination of the pair between difficulty and profit. So whenever I know, okay, I am standing on this 5, I have to go and search for all the difficulties which are lesser than equal to 5. Then I can do simply a binary search, or I can say I can simply sort it and I can do a binary search. Now again, when I say sort, I have to make a pair and then sort. Now if I do, okay, one thing I realized that for all the n's, for all the workers, let's say m workers, I can now go and search for any worker, any difficulty in my login time. But even if I check the difficulty, even if I mark, okay, this is the difficulty, max to max I can take, I have to grab what? I have to grab the maximum profit. In this case, it seems okay, Aryan, I will land onto 4 and the profit I'll get as 20. No, what if I had reversed this? What if this was 20 and this was a 10? Still, the maximum profit you could have got is 20, because you have to take the maximum in that prefix. So one thing we realize that, okay, Aryan, what I can do is I can simply go firstly sort this entire difficulty pair array. After sorting, I will start taking prefix maximum. Okay, 20, 20, 30, 40, 50. This is prefix maximum, because what if this would have been 50, this would have been 30, this would have been 40. Still, my prefix maximum would be 50, 50, 50. This will help us after doing a binary search and landing onto a value which is lesser than equal to my 6. I will land onto here. I know that I have grabbed the prefix maximum and I can take that. So we realize that how we optimized it. We optimized by saying, okay, I have m. For all the workers, I was going and searching for something in my difficulty array. I will simply sort it and then I will do a binary search. And after binary search, I was in a difficulty of what profit to choose. So I'll take the prefix maximum of the profit itself. Okay, that is one way in which you see for every worker m, you will just simply do a binary search, which is log n. And this will be pre-computed, which means when you will sort the difficulty array, which means n log n, when you sort the difficulty array n log n, you will also take the prefix maximum, which is O of n. And then binary for every worker, I'm doing a binary search on the difficulty array. This will be the complexity for me if I do a binary search. Now, same way, again, I'm saying as a same branch, what others could have thought of is that, Aryan, you said, okay, that for every worker, let's say for this, I wanted what? If I am at 5, I want for all the workers less than this difficulty, I want the maximum profit. If in a data structure you want to grab something maximum or minimum, what you use? You use a priority queue. So I could have also said that, okay, for this specific, again, I for sure have to sort it just so that I can iterate and keep on grabbing maximum as I go on and increase my worker of J. What I mean by that is that if I am at a 4, I should go and check for all the profits, all the difficulties which are lesser than equal to 4. And then out of all those, I can grab and simply take 20 as the maximum, because in my max heap, I am storing 20 and 10. But then the question is, next time when you iterate on 5, will you iterate again on this entire stuff of difficulty? Obviously not. That will again come out to O of m into n. I don't want that. So what I will do, I want that I should iterate on this difficulty array in the order itself. That okay, as I proceed further, my difficulty keeps on increasing, and same way I will iterate on higher worker array also. So what I might do, what I might end up choosing is, I would sort my worker array, sort my difficulty array. After sorting both the arrays, I know as I am progressing worker, as I am progressing to the next worker, which means as I am increasing my worker of I, my difficulty also increases. So if I am at 5, last time I was landing at 4. Okay. At 5, I might choose to go to, I might increase my pointer, which means I might go to 6. But okay, 6 is more than 5, so I cannot go. I will still remain here. Next iteration, I am at 6. Again, I will not start from very scratch. I might choose to increment it. Okay, only increment it. Again, it will have 50 in the data structure, and then I can grab from the max heap as a 50. So earlier, rather than using your binary search, now you did one thing, that you sort both the arrays, worker and difficulty, and then after sorting both the arrays, you realized that I would need to only iterate forward one step as I'm going forward, and just to grab the maximum, I can keep track in the max heap. Now, there's a small catch how the problem can be tweaked, and the interviewer can ask you. Now, max heap would have been required provided I would have given you a task that I can use one job at max once. Which means if a job 20 is used, I should remove that and should not use it again. But this is not the case. Again, I'm not saying that it will not work considering I can use 20 again. Okay, I will not pop it out from the heap. That's the best case. If I had an option, I should use job at most once, I would have popped out and would have never used it again. But in this case, I can use it any number of times, any job. So I will not pop it out. I will keep it in the heap itself. But if you're keeping in the heap itself, which means you're always accumulating in the heap and only taking the maximum value. So the question is, why even you need a heap for it? Can't you simply take a variable for it, and the variable will just keep on maximizing, That's what you were doing ultimately in your heap also. That is the crux, that I don't need a heap here. But I'm again iterating that if the problem would have changed to that you have to remove, you can only use a job at most once, then you will have to use a heap. Okay, now we realize that we only need to grab the maximum value up till that point. So we need no heap, we just need one variable, which is the maximum profit up till that point. As I was maintaining a profit maximum array, same way I will do 20, 20, 50, 50, 50. This will define me the maximum profit up till that point. What is it? It's simply that as you are at a specific worker, you will try to go on to your difficulty array, try to move right, but every time you are only moving. Okay, right now you are at 5. You thought of, okay, let's move further, but you cannot move further. Okay, you move to 6. Then okay, you realize, let's try to move further. Yeah, you can move further. Try to move as much as you can and try to maximize your profit variable. Max profit variable. And that's it. You're good to go. So you simply iterated O of m time. You simply did a pre-computation of sorting your difficulty profit array, which is n log n time. And then as you go on to all the workers, you will also parallelly go on to all the difficulties. Again, I'm saying parallel, which means 2 pointers, and then also maintain your maximum profit. Cool. Again, just for your compatibility, what we saw, that we will have to firstly sort. We have seen 3 approaches. First we saw brute force, then we saw a binary search approach, then we saw a max heap approach, then we saw a 2-pointer approach. All of them were super similar and generated or evolved from the same branches of requirement, that for a worker, I need the difficulty which is less than equal to, and out of that difficulty, I want the maximum profit. So one thing we realize, we need the maximum, we need to sort it. So as I'm on 40, I will iterate, okay, only go to difficulty less than 40. So I cannot go here itself. I'm actually technically here. So, okay, this will contribute a profit of 0. Okay, 25. You realized that you have already moved forward, which means if this would have been a 50, so you would have taken the maximum profit as 66. Okay, that's correct. But your maximum profit variable would have now contained 66. But now you are at a worker of 25, which is less than. So you cannot afford to move back. So do one thing also sort your worker array. You will sort your difficulty array, but you will also have to sort your worker array also. 25, 25, 50. And then iterate on that worker array in the sorted order. Okay, 25. Okay, less 0. 25 less 0. Here it was 42, I guess, or 40. Again, it is less, so it's 0. So answer is 0 in this case. Cool. Last example, for your just safety, as in like for your convenience, that I will have to sort this first. So 34, 45 and 73. I have sorted my difficulty profit pair. Again, I am right now 34. I will try to go to all the difficulty which is less than equal to 34. I will go on to my first value, which is 4. I cannot go further because it is 40, so I will still remain here. Maximum profit variable so far is storing 34. Okay, answer is 34. His contribution is 34 plus 45 is the next worker value. So I can go to all the difficulty which is less than equal to 35. So I'll just proceed my pointer further. I'll proceed it further. I can go to 40. Okay, I'll try to go forward. Look, I cannot go. It is more than 45. So I will still remain here. Maximum profit so far is 90. Okay, 90. So this contribution will be 90. Okay, then 73. So try to go to all the difficulty which is less than equal to 73. Okay, I can go here. Oh, it is ended. So far the maximum profit value will be 96. Okay, add the condition 96, and this is my answer. Cool. Let's see the code. It's pretty simple. Again, I iterate. We saw binary search, 2-pointer, and the priority approach. Now in this, it simply says that make a vector of pair, and then my n is difficulty, my m is worker. Then I simply can push my difficulty and profit in my pair, vector of pair, sort both vector of pair, difficulty and profit, and also sort the worker. Then I will iterate on my worker. I also have to pile check for that specific worker. I will have to see in my pair having a difficulty less than equal to my worker. I should check for that pair, vector of pairs, and grab the maximum profit. Cool. And then ultimately for the specific worker, update the, and basically add your, in your profit sum, add your maximum profit, and ultimately that's your answer. Cool. As you saw, this will take O of m space because you are making a new vector of pair, O of m space. Sorting O of m log n, sorting O of n log n. Again, this is a 2-pointer approach, so O of m plus n. Thus the complexity is O of n log n plus O of m log n in, again, worst case. I have not added n plus m because n log n is more than n. Cool. Now, again, we saw 4 approaches, but still, can you improvise it? Obviously, by looking at the constraints. The constraint itself, the worker value, the difficulty value, the profit value, everything is 1e5. It's a bit weird because we never ever used or tried to use my worker value. I always use my n or m. I never use my worker value. It is very less. Usually you will see that they could have given you 1e9 also. And if they could have given that 1e9 as a worker value, still in the above approach, it could have perfectly worked, perfectly. But with these constraints, can we take a help from it? How can we take it? We can simply take it if we know the worker is this much. Now what I was doing for every worker, I was going and searching for that worker in the difficulty array. For that, I was taking the maximum prefix, or I can say maximum profit in that prefix array. That's what I was doing. Now, can't I do the same thing by saying that I have to optimize my time? I know that I can use this worker thing also. So what if I make again, that is a bit tricky to think of. Again, the other approaches were like very fluent to think to like actually think and direct. This is a bit tricky. Like you might not end up thinking of DP itself in the first place, but if you know this, then now maybe you can think in the interview. Maybe I'm again saying, because it is not that much direct. So it says, okay, at a 4, you can just keep track of the maximum profit. That's what you want. And at 5, maximum profit, what you can achieve via this value, via this input. So I will say, okay, for a specific 2, I had a profit of 10. For a 4, I had a profit of 20. For 6, I had a profit of 30. For 8, I have a profit of 40. For 10, I have a profit of 50. Again, earlier I was doing what? I was sorting it. But then I realized, I know I was sorting it. Maybe I can take the inference of a count sort thing, because in a count sort, at indexes as values, you keep track as the frequencies. But here, my primary aim of sort was to get the profit. So I will keep the profit in those indexes. Indexes are the values of difficulties. So, taking the inference of a count sort, because I was earlier sorting, then I made this array. But then I realized I want to, again, because of this array being made, I know the values are always sorted. The values are always sorted. But in that also, I need what? I need my maximum. So I will take my prefix maximum. 10, 10, sorry, this is 20, this is 30, this is 40, this is 50. Again, you might say, Aryan, up till what point I should make? I will say make it up till 10 only, because you have values only up till 10. So make it up till 10 only. Now, okay, great. Now comes the fact that worker, for a specific worker 4, you will directly go and jump and ask your DP array, bro, give me the maximum profit. He will say 20. If the worker would have been 5, you will go and ask 5. It is again 20. For 6, it is 30. For 7, it is 30. That is how you can make this prefix array maximum, and that how you can use your answer. Again, I named this array as a DP array. You can name it as a prefix maximum array also. Now, there's a small catch. I highly recommend pause and code by yourself, but there's a small catch. What if I would have given the same difficulty value with a different, or I can say lesser profit? So this 6 would have been overridden to 20. Then I could have taken the prefix sum. But for 6, I have also 20. For 6, I have also 30. So I have same. I could have, for a same difficulty, I could have different profit values. So always take the maximum profit value. So I should make sure that I always, while building this DP array in the very beginning, I should always make sure to maximize my DP value, because I can, this could be repeated. Same difficulty value, I could have a different profit value also. So for that reason, make sure to always maximize, so that you are always obtain the maximum answer. Cool. And you might ask, Aryan, what if the worker value is higher, which is 12? Okay, if the worker value is 12, or maybe let's say even 100, which is not even in your array, if you will access that DP value, DP of 100, you will get a runtime exception. For that, simply take the maximum of your array, and that will be your answer. Because even if I virtually would have built the array of size 100, that would have been repeated 50, 50, 50, 50, 50, 50, 50. For sure, for 100 also, answer will always be this 50, which is the maximum value in my difficulty array and corresponding its corresponding DP value. Cool. Let's see the code. It's exactly same. How? Firstly, we define the maximum element so as to do like two major things. Build my this DP array, and also what if in future I get a worker value which is very high. So I can just compare and check if the worker value which is 100, which is more than my 10. So okay, I can also take my 10 as the DP of 10 value. That's the answer of for me also. So I got the maximum element. After the maximum element, I made the DP array. Then I simply went on and you see, I checked if my DP of difficulty of I is profit of I ideally, but I maximized it. This says that DP of 6 is 30. I could have overridden it, which means DP of 6 could have been 30, but I said, don't do this. Do DP of 6 is equals to maximum of DP of 6, comma, the profit value, which is 30. So that in future, Here, the DP of 6 will come as 20. So it will still remain, DP of 6 will still remain as 30. That's the reason I maximized my DP array. Now, next thing is making a prefix sum. So I'll take the prefix maximum. Okay. Now, simply went on to all the workers. For every worker, check if the worker of I is less than equal to my maximum element. So I can take the actual worker of I. If it is more, then I should take the maximum element itself, because if it is more, which is 100, so I should take the maximum element, DP of 10. That's my answer. And ultimately, with that, I did not do any sort, but I indirectly use something which my count sort does. Again, this is not count sort, because count sort, you maintain the count, which is the frequency. Here it is similar fashion stuff. I'm telling you how you can think of even. DP, how you can think of, again, you have to not take the array, you have to make something. Sorry, you have not sort the array, take something, then sorting not done, counting, okay, count sort says, okay, indexes to something, values as the frequency, but I here need profits, so I'll take the profits, but I need the maximum, so I'll take the maximum profit. That is how we went on and thought of that DP approach. So with this, it will be O of M plus N plus maximum element. Maximum element is actually 1E5, that's it. That is the reason. In worst case, it will be 1E5 only. Cool. And space for sure will be O of maximum element, which is again 1E5. And that can be your most optimum approach considering your worker value, or basically your difficulty worker, these values. In our case, it is bounded by difficulty array, but everything in the case question was bounded by 1E5. But if this would have been 1E9, this approach could not have been used. Cool. I hope you got it. See you, goodbye, take care, bye bye, and again join Discord and like बेबी सब्सक्राइब करना है जून से पहले 45K बनाना चाहिए. बाय बाय, टेक केयर.